Hello, Professor, and my respected colleagues. I'm Dhruv Shah is here to give presentation on my topic grounding and bonding. First, in this presentation, I will give a brief description on definition, reasons why grounding and bonding is required, basic concept in commercial and industrial areas, types of grounding and bondings, advantages and disadvantages of grounding and bondings, and in the end, conclusion. First, what is grounding and bonding? There is a common misinterpretation that grounding and bonding are the same topic, though they are connected to each other, but they are not the same. Bonding is a permanent joining of metal parts together to form an electrically conductive path. It has a capacity to conduct safely any fault current likely to be imposed on it. While, on the other hand, grounding is a permanent and continuous conductive path to the earth with sufficient ampacity to carry any fault current liable to be imposed on it. And sufficiently, it provides a low impedance path for voltage rise or more ground and to facilitate the operation of protective devices in the circuit. The following figure shows the basic grounded wire and bonding jumpers of an equipment of a utility transformer. Now, why grounding and bonding is required? First, it protects the life from danger from electric shock or property from any damage by bonding to ground non-current carrying metal systems. It also limits the voltage on a circuit when it is exposed to high voltages due to electrical surges or lightning. In general, to limit a circuit voltages to ground to 150 volt or less on circuits supplying interior wiring systems. Fourth, to facilitate the operation of electrical apparatus and systems. And fifth, to limit the voltage on a circuit that might otherwise occur through exposure to lightning. Now, basic view of a commercial grounding and bonding. In this given figure, let's start with how the power starts from an utility ungrounded hot wires to a home system. It moves through the feeder wires into panel boards, through circuit breakers and into branch circuit wires, and returns to the source from the home grounded wires. Now imagine a scenario in which lightning strikes to the nearest transformer, utility transformer, or consider a high voltage wire falls on a administration drop. If there is no grounding at the home, then voltage surge has no path to ground to take a shelter, which may result in arcing of all the electric arcing and which might damage all the electrical equipments, that is transformers, TVs, plasmas, motors, etc. Sometimes it may also result in fire hazards. So if there is a grounding system in the home, then it would provide a low resistant path to return the high voltages. Now it follow this system follows Ohm's law. Is I is E by R. Suppose E is 120 volt and R is 10 ohms, then I would be 12 ampere. This ineffectively fortified circuit will convey 12 ampere, but this 12 ampere circuit won't trip a 15 ampere electrical switch, but it could possibly will. But this is a sufficient current that would possibly kill a rodent or any other individual which comes in contact with the system. Thus, grounding and voltage grounding is important in electrical systems. Types of grounding. Now, there are basically three types of grounding: ungrounded systems, solidly grounded systems, and high resistance grounding. Ungrounding systems. Ungrounded systems are which are worked with no deliberate association with ground are portrayed as ungrounded systems. They usually offer the low estimation of current streams, but there is a drawback of ungrounded system that there are in that system it's hard to find line to ground faults. Solidly grounded systems. Solidly grounded systems, most ordinarily used grounded systems so far. They are used as a part of mechanical and luminous power frameworks where established conductors are grounded with no impedance in the circuit. High resistance grounded systems. In high resistance grounded systems, there uses sensing resistors to sense the continuity of the system. Th- uh, These systems limit the fault current to 25 ampere or less. They are mostly used in big plants and factories where procreated with operation of procedures is important in case of a flow. This figure shows the basic star connected system arrangement and voltage relationship of different grounding systems. Now comparison of different grounding systems. The comparison of different grounding systems, equipment damage, over voltages in ungrounded system, the effect is very severe. In solidly ground system, there is no effect at all, and in low and high resistance grounding systems, there is a limited slight effect of over voltages. Overcurrent damage at one point of fault. In ungrounded systems, it's difficult to judge the fault at a point. In solidly grounded system, the effect is very severe. In resistance grounding systems, low resistance grounding systems, it is very minimum, and in high resistance grounding system, it is not at all. Maintenance cost. The maintenance cost of ungrounded system is the highest, while it is reasonable in solidly grounded and low resistance system, while it is low in high resistance grounded system. Downtime. Continuous operation with ground fault, possibly but not recommended in non-grounded systems. It is not possible at all in solidly grounded systems and low resistance grounded system, while it is ideal in high resistance grounded system. Relay coordination, appropriate equipment tripped, ease of fault occasion. It is difficult in ungrounded system and thoroughly grounded system, while it is good in low resistance grounded system and it is best with high resistance grounded system. Safety to personnel. And in ungrounded systems, it is very poor, while in solidly grounded system it is good. In it is excellent for high resistance grounded system. Now types of bonding. There are two types of bondings in electrical system: equipotential bonding and aircraft electrical bonding. Equipotential bonding is nothing, it includes joining together metalwork that is or maybe earthed with the goal that it is at the same potential, that is voltage all over. Such is usually utilized under transformer banks by force organizations and under substantial PC establishments. Equipotential bonding is done from the service panel purchaser unit to approaching water and gas administration. Aircraft electrical bonding. In this electrical bonding, foretells friction based electricity developed that can meddle with radio and navigational gear, allowing so as to hold likewise gives lightning insurance the current to go through the airframe with least arcing. Bonding avoids hazardous static releases in air, ship, fuel tanks, and hoses. Advantages of electrical grounding and bonding. First, it shield life from the risk of electric shocks from harm by bonding to ground non-current conveying metal frameworks to restrain the voltage on a circuit when it is present to higher voltages that for which it is composed. By and large, to restrain a circuit voltages to ground to 150 volt or less on circuits supplying inside wiring frameworks, to encourage the operation of electrical contraption and frameworks, and fifth, to restrain the voltage on a circuit that may somehow or another happen through presentation to lightning. Disadvantages: chemicals concentrated around terminals will cause erosion. Chemicals filter through the dirt and disseminate. Scheduled renewal may be required, may be disallowed on the grounds that they may debase the water. Conclusion. Thus, I want to conclude my topic by saying that overcurrent device protects against ground fault conditions provided that our circuits have been installed so that all conductive metals are bonded together and to the service neutral. Grounding is an association with earth planned to shield our electrical framework from lightning and high voltage. The overcurrent device protects our electrical system from overload and short circuit, while proper bonding has created a permanent and electrically continuous and low impedance path, which allows fault current to return to the neutral at the surface. These are the references which I took to make this presentation. Thank you. Any questions?